Hi, and welcome to Chapter 9. Chapter 9 is on database design. We've spent a lot of stuff in the last couple of chapters writing SQL queries and understanding a little bit about how that database is built. Now we're going to kind of step back and do a little bit of theory on the best ways to actually design your database and what steps we need to go through to do that. Let's get started. The first part I want to talk about is information systems. It's simply a terminology to refer to the ability to retrieve, store, access, and manipulate data. So remember back when we first started talking about the difference between data and information. An information system is a system that is completely designed to manage that information. So not just data in and of itself, we could store that in a flat file, we could store it in Excel, we could store it anywhere. But an information system is an entire system to manage that information, to make sure that you get what you need when you need it, make sure that you store it correctly, that you have that data integrity that we talk so much about. An information system is set up with both system analysis and system development. So analysis is simply analyzing the system that we want to build and making sure that it is possible to do everything we want to do to determine if there really is a need for an information system in this situation. And then, of course, the development is the process of actually developing. So writing the database, writing the application, moving on. Your performance in an information system is really, really important. If you cannot retrieve your data fast enough, if you can't get hold of it, if it's incorrect or it doesn't have that data integrity, your system doesn't work. And the performance can be based on how you designed your database, obviously, and how you implemented it. And then, of course, your application itself. So how the users, the end users, are using it. And then there's a third part that a lot of people forget about, which is your administrative process. Every time that you create a new website, for instance, and it's going to go do something, say a shopping cart. Okay, cool. I'm going to go build the shopping cart. I'm going to make it so that I have all my inventory and I show that to the users. They can click something, put it in the shopping cart, buy it, move on. Well, that's great, but you also have to set up an administrative section. Where are you adding new inventory? Where are you checking inventory values? Where are you updating prices? Because you're going to have administrators that are not going to have access directly to your database to be writing SQL queries against it. You're going to also have to have administrative procedures in place. So it's really important that you think about that when you're designing your entire information system. And the last part of information systems, of course, is the database development. When you develop your database, how are you going to do that? What DBMS are you going to use? How are you going to connect to it? How is that all going to be associated? So these are the things that are really important in an information system. Remember, a system that is going to encompass a whole lot of different things. It'll be the back-end database, it'll be the front-end application, it'll be how your users interact, how your administrators interact, and how any of the people in between work. So if you have taken any type of a software development course at this point, you know about life cycles. We've talked about waterfall, we've talked about agile, different life cycles of how we do development of software. System development has its own life cycle. So when you're creating a new system, you have a life cycle that you're going to follow. Same way that we would follow a waterfall or an agile life cycle if we were doing software. When we do our system development, this part of this chapter is a bit long and they go into more detail in each one of these different categories. So it's important that you understand the different parts of system development lifecycle when we create our system. Starting from the top, planning. Obviously, you're going to go talk to your client and you're going to start planning. When you plan, you need to think about a feasibility study. You need to look at, is this even possible? Is this something that the user can afford? Is this something that the client can afford? Is this something that they need? Is this something that is a problem that is so significant it benefits from the cost outlay, and so on and so forth? In a perfect world, nothing costs any money and we can do everything we want. But in the real world, everything comes down to cost and time, requirements, what we have the ability to do. So you're going to start in your planning stage before you do anything else, and you're going to find out, what does the client want? Is it possible, and can they afford it? Once you get through your planning stage, now you can start analyzing. Now you go back for your second meeting with the client and you go, okay, we need to get down some business rules here. We need to look at our user requirements. What kind of reporting do you want at the end? What kind of information do you need the users to be able to see? How do you actually see this working? And we're going to start sketching out what their current system is, and then how our new system is going to benefit or is going to be an improvement on that. Obviously, if your new system is not an improvement, then there's no point. So you need to see what the old system was. If it was just pieces of paper that they were moving around and now they're putting them in database, yeah, we can point out a lot of ways why this is better. If they had a current system, why didn't it work? What were the problems that they ran into? Because you'll probably find that somewhere along the line when they built the last system, they didn't do this step of figuring out the business rules, and they didn't do the step of figuring out user requirements. And so they built the database or they built the entire system without knowing all that stuff. So you're going to stop and you're going to go, I'm going to write all this down. I'm going to write down flow charts of workflows, and I'm going to start understanding what are the business rules in this situation and how can I make a system that makes that work. This is also the step where you're doing a lot of talking, not only to the client themselves, but the end users. It's one of the most important steps in building a new system. Talk to the people who are going to use your system. Ask them what they're doing now, figure out why they're having problems. Make sure that you build your system for the people who are actually going to use it. Next, we're going to go to the detailed system design diagrams. In our detailed system designs, apparently I have it written twice. I think it's design. You're going to build your workflow diagrams, design your reports. You're actually going to sketch out your interface. You're going to say, this is what the page looks like, and this is where the header is going to be, and this is where the menu is going to be. This is how this is going to move forward. If I have a wizard, how this page is going to go to the next. Design the interface of your final application with your user in mind, with your client in mind, and get their kind of sign off before you get started, because you may find they're going to say, well, that would be stupid. I'd have to write the same information twice. Or I'm looking at a form that tells me 3 of these pieces of information, but I'd have to go find the other 4. How can I do that? And you're going to go, oh, well, if that's how it's going to be, let me redesign this. Let me look at it again and figure out what I'm doing wrong or how I can make it better. So when you're doing your system design, you're going to go through and sketch out that information. You're going to make sure that you understand your entities, and you're going to understand your database, and you're going to understand how the data is going to work together. Remember, this is a whole system. This isn't just databases we're talking about right now. This is the whole system. Once we have that whole thing designed, which can take a while, and I do recommend writing it down, getting a design document, making sure that your client signs off on your design document, because as you build this thing, you're going to find that clients don't always do what they say they're going to do, or they're going to say, oh, wait, we forgot to tell you about that. So making sure you have that conversation with them, really, really important. Next step, 4th step, is implementation. This is where you actually go write the code. So you go write your code, you go build your website, you go test it, you debug it, and you install it. And there's this step called fine-tuning. That's where you realize, oh, wait, I thought that this should be a varchar, but it's actually going to be a Boolean, or it's going to be a number, or something along those lines. You also want to think about how you are converting your old data into the new system. Because at some point during this implementation stage, you're going to take all the information that they have and make it into your new system so that they can start. They can't use it if they don't have the old data in most cases. Sometimes that's going to be writing a script in a scripting language, F#, C#, Python, Java, something, JavaScript, to be able to take old data. You might be taking it out of an Excel spreadsheet. You might be taking it out of an old database. You might be taking it out of pieces of paper. So you're going to need to have screens for your users to do some data entry if that's the direction you want to go. So you need to think about how are you getting the old data into the new system. And the last stage, which is not always the last stage. So sometimes with implementation, you can turn around and go back to your design. That's okay. You can go back to your analysis, and you can go back to your planning when you realize, oh, wait, we just added a whole new set of features. I wasn't prepared for that. Let me go back and check feasibility again. So all of these steps, while I have them listed here as an arrow going down, they can all go back around in circles, just like any life cycle. And finally, we get down to maintenance. Maintenance is where you've installed it, the system is working, the users are using it, and we think we're good, we're in the clear, let's go do something else. No, we don't do that. We stick with our product and we keep an eye on it. We do maintenance, we do evaluation. 2-3 months after you've implemented it, go talk to the users again. How's it going? Did you find any points that suck that I need to fix? Any things that, gosh, wouldn't it be nice if we had a drop down for a calendar here because we keep typing in dates? Could you pull this piece of information and pre-fill it in for me? Talk to your users after you've done and look and see, is there things I can do quickly so I can just add new features on the fly? Or is this something that we're going to have to do a new version? Like, there's not enough information here. We're going to have to start back from another plan to take this and modify it. There are 3 different steps in maintenance. Corrective, obviously fixing errors. Adaptive, fixing design errors. So this is where everything works, it just doesn't work well. And then of course, perfective, to make it better, because we like to make things perfect. This is where sometimes Visio and some of the other computer-aided software engineering tools are going to come in, because you're going to start drawing things out and you're going to say, okay, this is how this works, so on and so forth. Okay, so this is your basic system development life cycle. When you're starting a new system, this is the steps that you go through, and you want to make sure you hit them all, because every one of them is important. If you skip the feasibility, you may get all the way down to implementation and realize you can't afford the database. If you skip your existing system evaluation, you may realize that you're actually making a system that's worse than what you started with. So each of the steps are important. Go through them all. Let's go on. Okay, so after the system development lifecycle, we're going to do a database lifecycle, so DBLC. And we're actually going to go through each of these different steps and explain them a little bit better, so each one has their own slide, but I just want to touch on them to begin with, and then we'll move on to some more descriptions. Again, we're going to start with an initial study, just like we did with system development. We want to start with figuring out what the system is. Then we're going to design our database. This is where you select your DBS, create your designs, your ERs, your ERDs, your UMLs. Start building it. Start designing it on paper. Don't write anything in code yet, but write it all in paper. Next, we're going to actually implement. This is where you install your DBMS, you run your create statements, you load and convert your data. You notice we got all those done, and we still have 3 more steps to go. Don't be surprised. Underneath that, we're going to do our testing and evaluation. We need to test our database, make sure that any of our triggers happen correctly, make sure that our data is being held correctly, and that it's doing what it's supposed to do for what we needed. Depending on what your application is in the background, you may need to modify your database just because it's inefficient to run 13 joins to get all the data because you over-normalized. We're going to fine-tune our database at this point, change around, alter things, and look at the DB and the application together and evaluate that. Look at it and say, okay, is this going to work? Are we going to get the data we need to put this into our application? Next, we move on to operation. This is where it's actually an operation. It's live. We go live, and the database is all being used. And finally, again, we don't stop there. Yes, we did our job and we walk away. No, we maintenance. We do introduce any changes that we need to make. So if we realize that we made a mistake with something, or someone wants to add more data later, like, oh, wouldn't it be nice if we had a Boolean field here? Could you add that? Introduce changes, and then make enhancements. Again, make it better. You know, this is your job to do the best you can to produce the best thing for your users. Do the best you can. Keep adding to it until it gets it as close to perfect as you can. All right, so the initial study stage, this is the first stage where you talk to your clients, talk to your users, figure out what's going on in the company. A couple of different steps with that is the first is analyze the company's situation. Now, this is kind of funny. Go figure out who's in charge, who the guy is that's paying the bills, who's the guy that's using your system, who's the guy that's his boss, who's the guy in the middle that has some knowledge and you're actually replacing his job by putting the system in. Figure out what the maintenance, the entire system is of what's currently in place. What does the company do? What is their mission statement? Why is the company in business? Because as you understand more about your client, the more you will understand how the workflow works. So take some time, give yourself the time to talk to your clients, figure out what their goals are in the universe. Next, start talking about the problems and the constraints. Problems being, why does the current system not work? What are they currently doing that doesn't do what it needs to do? Why do they need to change? Why do they want to change? What are their pain points? In the book, there is a section on narrations of conversations between people, clients that you would be having. Go ahead and read them. Aside of the fact that they are relatively accurate of how client conversations can go, it gives you an idea as to how different people in different job positions see the problems differently. So if you're in a management position and you can't get your reports fast enough because your user can't figure out what to do, his pain point is that he can't get reports. But if you go back to the user and you ask him, he's like, they have me doing 5 different reports that are all different subsets of data, and I don't know how to do that, and I don't know what I'm doing, and I feel like I have to recreate the wheel every day, and it's frustrating. So you'll talk to them and you'll go, okay, I see now. I'm seeing why you guys are having trouble with this, and this is how I can fix it. One of the things that I've added from my personal experience is please be patient and try very hard not to offend anybody in the room. It sounds kind of stupid. Obviously, you would never want to offend anybody. But think about it. Everybody who goes to work thinks that they're doing a very good job at their job. Very few people continue to go to work and think that they suck. So try not to say, oh my God, you mean that guy couldn't get his stupid report done? He's so lazy. Yeah, he's sitting right next to you. Try not to offend him, because you need all of these people to be on your side when you're talking to them about building the system. You need them to be honest with you, tell you the truth, and you can't let them have a personal issue with you. So try very hard to be polite and respectful. Try not to offend anybody while you're having these conversations. I know it seems kind of obvious. Also recognize that there is a difference between what is perfect and what is possible. There are always limitations, constraints. We only have $20,000. We only have 6 weeks. We only have 2 users. These are our limitations, our constraints on our system. And we want to make sure that the developer, that would be you, understand how those constraints work. So you may offer me the world, but when you turn around and you say, okay, I'll build you an entire system for $30,000, and they're like, we thought it'd be like 10. We can't afford 30,000. What, are you kidding? We don't know. Yeah, there's no way we could afford that. Yeah, try to understand the constraints before you get started, because if you can do that in your initial study, it'll save you a lot of time later of building ERDs and building designs, and then having the client come back to you and go, yeah, that's not going to be possible. After you figure out your problems and your constraints, figure out your objectives. What did you learn from all this conversation with all these people about the system, and start building your plan. How do you think you can build this system to make it work for them? This database is going to solve their problems. What can you do? And figure out their objective. Make sure you solve the objective that they want you to solve. Sometimes new developers will walk in and go, oh my gosh, I can solve everything because I can fix this and this and this. And the client's going to look at you and go, but we don't want you to fix that. We like that. We like the way that it's working now. And you're like, no, it's terrible. It's not efficient. It doesn't do what it's supposed to. And they're like, no, we're good with that. I want you to solve this other problem that you completely ignored because you went off onto, your own tangent instead of listening to us. So it's really important. Figure out what your objectives are and make sure that your system solves those. How is the new system going to work with the old system? And this is always a little bit touchy, especially if the developer of the old system is still working there. A lot of times in the real world, you'll have somebody who works at a company and he will have designed a system. And it may not be perfect, and it may not have been done by a database administrator or a database developer. He just did it because he had no choice. He had to solve the problem. And he built a system that wasn't perfect. Be careful about completely cutting that out or in any way, again, insulting that. He did the best he could. This is what he was given. Be grateful that something was working, and see how you can work with the old system. Can you share your data? Can you transfer data across? How can you bring that old system into the new system? The next section is your scope and boundaries. So just like in code, this is where things are valid, things are acceptable. How far into this design do you want to go? If you're working with the HR system at a big company, do you need data from sales? Do you need it to be department specific? Is this going to be implemented across the whole company? What is the scope of this product? And of course, boundaries, cost, time, resources, and the existing decision system. Cost and time are the big ones. Resources is pretty close second. These come into every conversation in your initial study. This is the cost. This is how much it's going to cost me to build this. Be honest. Don't lowball yourself so bad that you're working for, 50 cents an hour, which I've done. Make sure that you recognize your worth, but recognize your worth to the company, the client. You are building a system, and make sure that it's worth it. Don't get greedy, maybe, but don't also shortchange yourself. So look at those cost and time requirements and be honest about them. Don't tell them you can build a whole system in a week if you can't, because now you're just lying to them and they're not going to be very happy about that. So even though they say, oh my God, we need it done, and you're like, yeah, can't. It's going to take me too many hours. I'm sorry. The best I can do is give you 3 weeks. And that's me working full time. That's the best I can do. So be honest with yourself, be honest with your client, that time and cost. The next section is on database design. And this one, of course, is also going to get broken down. So I'm not going to go over too much of it. But there's the 4 sections of database design. So there's conceptual, where we're going to do our ER modeling and we're going to normalize. We're going to do our data analysis, all in conceptual stage. We're going to pick our DBMS. So if you're going to pick SQL Server, you can pick Oracle, pick MySQL, whatever that is. Then you're going to convert your ERs into a logical ER. So you have conceptual, you can have M versus N or MN relationships. Convert it into logical at this stage, where you're going to do additional normalization, deal with your integrity constraints and your user requirements at this stage. And then the last one is the physical, getting into the actual storage and security measures that have to go into it. Again, I'm going to do a different slide for each of these, so I'm just touching on them here to give them to you, and then we'll keep moving on. We're going to finish the database lifecycle, and then we'll go in and describe these. So after our database, we're going to do our implementation. So we built all of our ERs, we built our entire database, we've gone through all of the steps that you've learned up to this point. Now we're going to implement and load our database. So we're going to install our DBMS, create your database. This is where virtual servers or virtual machines come in. The Azure is, of course, a virtual SQL server. It's not on my computer, not here. It's up in the cloud. That's an option. Make sure that you know that your client's options, and you should have resolved this question way before this stage. So you should already know where you're putting this. If it's on a machine in the client's office or if it's on the cloud, either way, install your DBMS. Actually run your create statements, grant your users permissions, so on and so forth. So you're going to do all your create statements here, inserting your new users and all their permissions. And then, of course, the loading and converting the data. Again, you should have already thought about this. How are you getting the old data into the new system? So you're going to run through whatever process you talked about, whether you were writing script, whether you were using code, whether you were creating a user interface for manual entry. So this is your implementation and loading stage. Your database is actually getting into place. The next stage after this, of course, is your testing and evaluation. So we have to look at our database and we have to go, okay, crap, is everything working okay? Test it for physical security. Can someone come in and take your data straight out of the database? Is it physically secure? Your password strength, make sure that you talk about your password securities, make sure that that's set up correctly. Your access rights, who is able to do what? And this is where it comes into, do you want to have every user can do everything? Do you want your application to be able to delete the database? Well, God, I should hope not. Unless that's something you want them to do. Can they delete users and add users? Well, yeah, probably in the admin section, but we need to think about access rights and how things are being done in your application. Your audit trails, this can sometimes come back and be a big one. If you need an audit trail, you'll really wish you had one. And that's where we keep in track who accessed what, who wrote what queries, who did what things, because someone's going to come back and go, wait, this data is wrong, who broke it? And you want to be able to have an audit trail you can point to and say, yes, John Doe did this at this time, he went in and he updated this data. It's important to keep an audit trail, and that's something you have to think about while you're designing your database as well. Where are you storing audit trail information? Are you just keeping a log that's just going to sit in the back, or are you going to store it in database? Your data encryption, some of the data that you're going to be using is going to be secure and confidential, and you need it to be encrypted. You can't have it just sitting in read-only or in readable text on your database, because anybody can see your database, anybody who goes back to that security thing. So some data you may have to have encrypted in your database, and you need to think about that. Is it properly encrypted? Your password should never be in plain text in your database, so that a DBA could go in and search and get an actual version of your password. You should never have that. So if you're ever storing a password, you should always hash it. You should always encrypt it before you store it anywhere, and then unencrypt it when you want to compare it. But you should never have anything like a password in just normal text. And then, of course, the concept of a diskless workstation. So some workstations do not allow you to download data. Is that okay? Think about how you're writing your application, and is your application in such a way that you need to download the data and then deal with it on client-side scripting, or are you using server-side scripting for everything and you're not going to use any client-side downloads of any data? So think about how you're going to handle that part of the information. Next, during this stage, we're going to fine-tune it, adding our indexes, making sure that our queries run correctly, if there's any buffers that we need to do, if we need to put some data across and hold it in state, if we need to store cookies, things like that. And then we're going to look at our database and we're going to say, does it work? Is everything working okay? If it is, let's start talking about how we're going to back it up. So there are 3 different ways to back up data from a database. There's the data dump, which is just the whole thing. All of the data objects, all of the data, everything stored. It is huge. We like to avoid data dumps. Differential backups, which is where we only save things that have changed since our last backup. So our first backup is really, really big, and then every backup after that is really small because it's only the changes in between those 2 backups. And then there is a concept of a transactional log backup. The only thing that we store is the log of everything that has been done. This insert query, this update query, this delete query. All of the different transactions are stored in a log, which means if you need to recreate the database, you start from 0 and you run the transactional log, and it runs all those queries again, all those inserts, all those selects, all those updates, and creates the entire backup from rerunning all of those transactions. So sometimes this is more efficient, especially rather than storing huge amounts of data, you're just storing a bunch of SQL queries. And sometimes that can be easier. Okay. So now we're going to talk about operation and the maintenance and evolution, because they're kind of both the same thing. In operation, this is where we go once our database is considered live. In any system, you're going to have a point where you say, okay, we're live. Now people can use it, and I'm okay with that, and everything should be working fine because I've tested like crazy, and I'm pretty sure it works, and we're going to go ahead and make it live. While it's live, keep an eye on your resources. Look for bottlenecks. Look for problems of locked tables because too many users at the same time. This is what happens with any of those government websites where everything was fine until people started using it, and suddenly you had 30 million people hit it at the same time, the whole thing crashes. This is what happens. When someone designed it, they never tested 30 million people at a time, so they never knew that the resources were going to be hit so hard. Talk to your users about problems that you didn't catch before when you were doing design, because that's going to happen. You're going to talk to your user and you're going to say, what's going on? And they're going to go, everything was fine except this thing, which is really irritating. Could you fix it? So look for those. And then, of course, your maintenance and evolution. Back to that preventative, corrective, adaptive. So preventative, we're going to do backups to make sure that we don't have any problems. If there are, we can bring back a backup, use recovery, or corrective, and then adaptive by adding new features. Keep an eye on your performance. Like, look at it every day, every other day for a couple of weeks. Make sure that you don't have any problems with performance. No one says, oh my gosh, this query takes 2 minutes for the page to come back. Shouldn't be doing that. What's going on with performance? Look at your security audits, your audit trails. Remember, that's what they're there for. Look at those and make sure everything's good. And then talk to your client about, okay, 6 months later, a year later, how's it going? What can we do for the new version? Okay, so we're back to section 9.4, which is on conceptual. So this is in the middle of that database design that I said we'd come back to and we'd hit different slides on. So talking about our conceptual design, and this should feel a little like review because we've talked about this before, about the different design steps. So a lot of these steps should feel like, yeah, I got that. We're already covering that, so I'm good. Your data analysis and requirements, get your information. Look at the existing system, talk to the end user, get your business rules. That's all in your data analysis and figure out what your requirements are. Then you're going to do your ER modeling. You're going to get your business rules into entities, relationships, attributes. You're going to create your initial ER diagrams. You're going to normalize the first time. You're going to refine your diagrams, and you're going to validate everything that you've gotten against the user requirements. Look at your database and go, is this doing what the user needed to do? We're going to go into a data model verification stage where you just verify, can the end user get the information they need? Is the central entity something I can point out? And this is going to sound kind of funny. Every database generally tends to have, or at least every module in a database, tends to have a central entity or some item that is the center of it. If it's a sales thing, it could be the product, it could be the invoice. What is the thing that is central and everything breaks off of that? If it was HR, it could be the employee, it could be the job description, it could be a lot of different things. So each one of your modules is going to have kind of a central entity that is going to be the thing that is in the center of it all. You need to figure out what those modules are. If you need to break it up, sometimes that happens. Depending on how your system is designed, you may break it into different modules. This is my employees, this is my students, this is my class structure. Breaking into modules will help you to understand the requirements of each module individually, and then you can check the requirements of each module and make sure that they solve your end user requirements. The next little section is more on chapter 12, so we're just touching it. It's called a distributed database, and if we need to distribute our database, if we need to break up our database into fragments and store them in different locations, we have an entire chapter on database distribution, so I'm not going to go into it now. We're not going to have a whole lot on it on this chapter, but it is something to think about in that conceptual stage. So the second step of that was our DBMS selection. I have been pushing you guys with the SQL Server because it's the one that I use frequently, and it's one that I have a lot of knowledge with. I also think that it's easy to use, but it's also robust enough to give you some real world examples. That doesn't mean SQL Server is the best database for every situation. And I will definitely tell a client, no, SQL Server is not the best one because of this and this. You really should go with MySQL. You really should go with Oracle. You should go with something else. Couple of different sections to think about with DBMS selection is your cost. Cost is not just purchase price. It can also be your maintenance, your license costs, your licensing costs, your training, and your installation. If you have a DBA who is on your staff who knows everything about Oracle, don't go get SQL Server, because why would you do that? You pick to your strengths. What is the knowledge that you have in-house? What is the knowledge that you're comfortable with? So these are things to keep track of when you think of cost. You don't want to retrain everybody in a new DBMS if you don't have to. What are the features and tools? Some of the DBMSs have the ability to do report generation or your data dictionaries. How do you feel about those? And then, of course, the querying itself. Is that something you're comfortable with? When we talked about scripting with Chapter 8, you have your PL SQL versus your transactional SQL between Oracle and SQL Server. Do you need to have a procedural language? Is this something you need? Because we could definitely do something smaller that is less cost, that has less cost if you didn't need that. So think about the features and tools of the DBMS. What type of model do you want? Do you want a relational model? Do you want an object-oriented model? Do you want it to be networked? Do you want it to be hierarchical? Do you want it to be a key value pair, like we talked about with our NoSQL? Can it be used across platform systems and languages? And is that something that you care about? Is this something that needs to be accessed and it's easier to use one versus the other? So think about portability across different platforms. What are the requirements for the hardware? And I'm going to tell you now, all databases need huge amounts of storage. They also need some pretty good RAM and some pretty good processor speeds, because if you're going to be running queries against the database, you're going to need to be able to get that information out. And that's how the RAM and processor kick in. And then, of course, what is the current knowledge in your house? So in your client, what is the knowledge that they have, and how can you build a database around what their current knowledge is? All right, so we've done conceptual and we picked our database. Let's start building into logical. Remember, we can't do logical until we know which database, because that'll change how we converted from our conceptual to our logical based on our DBMS. You want to think about your strong entities and our weak entities. You want to think about your supertypes and your subtypes. You want to think about your binary relationships, so the ones that are between two tables, and your tertiary or any higher degree relationships, the ones between three tables. And you want to start mapping those out, getting those really comfortable. You can't have end-to-end relationships at the logical stage. So this is where you clean those up. You start making them into those middle tables where you can start making sure that the data is actually usable. Then we go into normalization. Definitely normalization is a huge step at this point. You're going to resolve your multi-values, your partial, your transitive dependencies. And you're going to look over your attributes again, and do you have any unwanted duplicate data? Look at the data. Look at the actual text fields and go, oh my gosh, look, we have first name, last name in this table and in this table. Why are we doing that? So make sure that you didn't miss anything in making sure that your data is normalized. Check your constraints for integrity. Make sure that your data types are good. At this point, you're going to start writing out data types. So you're going to start saying, look, this first name, I'm going to make him a varchar that's going to be a max. I'm going to make him, you know, the area code is going to be a varchar that's a 3. Maybe it's going to be a numeric that's only 3 digits. Check your cardinalities, because you need to write down at this point if you have any requirements that you're going to have to write in those create statements for your create tables to limit values. So if you have any min or max requirements or anything that you need to check to make sure data does not fall outside of the requirements. And again, determining your database data types. And then validate your user requirements. You notice we keep coming back to the user requirements. You keep hitting it over and over again. Did you hit your user requirements? Did you forget anything? Did you look back at your user requirements and go, wait a minute, there's a thing in here I completely forgot to implement. Let's go do it now. Yep, go fix it at that point. So this is your logical design. The last part of this database design section is going to be on physical design. And in all honesty, you don't usually have to do too much at this stage. You need to know what your data storage is, where are you going to store it, how is it being stored. Data storage is important. You're going to identify your indexes and any views, virtual tables that you want for any of your data sets. If you look at it and go, gosh, you know, the majority of things want to know what an invoice is with each of the lines as a single table all the time. I'm running this query all over the place. We're going to make it a virtual table. We'll make it a view that the user can just grab the data from the view, and they don't have to do that join every time. It's already done in the view. And then, of course, your indexes. You're going to do your integrity and security measures, so make sure that you have your users, your groups, and your roles. In database design, you can say you are a reader, you are a writer, you are a contributor, you are a DBA. And as such, you have certain security controls on what you can and can't do with your data. So it's important to be able to define those and make sure that those are all figured out in your physical stage before you actually go start implementing. And the next one is your performance measurements. This is going to be a little hard until you've actually built your database, but you're going to make sure your queries run efficiently. Chapter 11 is going to do a lot in database tuning to make sure that your database queries will run as efficiently as possible. And we'll talk about how database queries are done, what pieces of the query get run at what time, and how those all get kind of munged together. Okay, so that's a lot about our database and how we're going to build it following that database lifecycle. You can design your database from the bottom up or the top down, and this is completely up to you. It's your database. You figure it out. The top down starts with the entities and builds down to create your attributes, whereas the bottom up starts with the attributes and builds up to create the entities, grouping them together. We just want to keep drilling this into your head. Some people feel more comfortable going from the bottom up, some go from the top down. You will find neither of them works perfectly. That there is no perfect answer. There's no right answer here. Generally, you start kind of with a top down, then you realize you have attributes, then you start adding them back to groups. You gotta go all over the place. So while it's a strategy to follow, it is not a set in stone plan. It is not a GPS, let the GPS tell me what to do. This is kind of, you're gonna kind of go east for a while, then you're gonna go north for a little bit, and we'll go from there. You also have the option of centralized versus decentralizing your data. Centralized databases, the way I like to think of them are, it is a database that can be conceived of and completely understood by a single person. When you as a single person can understand every single table, every relationship, every key, and feel comfortable knowing everything in your database, probably no reason not to be centralized. Single, simple database, you should be fine. When you start breaking out your database into modules and you start to realize there are 423 tables and I haven't a clue what all of the different relationships are. I kind of know there's some HR tables here, there's some sales data here, there's some management here, there's some customers here, there's some clients there, and I'm kind of confused. You might have multiple DBAs. A lot of the bigger companies that have large database systems are going to have multiple DBAs, and you're going to be only in charge of one section of that. It is decentralized. It is not a single person. It'll be broken down into modules. These usually have complex relationships with lots and lots of entities. Like I said, 300-400 tables is not an unusual size. And you might have multiple DBAs that each kind of take their own module. So that's kind of how I like to visualize decentralized. It cannot be centralized into a single person. You're going to have multiple people understand it. Now, you could have a great DBA that understands it all, but more likely you'll probably have a couple of DBAs because it's just going to be that much data. All right. So this was chapter 9. Chapter 9 was a lot of theory. So you notice we didn't really give you any new SQL things to think about or even really any new diagrams to write. We just gave you a lot of things to think about. Your information system, managing your data. That's all it does. Data runs the world. Everything runs on data right now. So being able to manage your data, good place to be in the world. Your systems development lifecycle is your planning, analysis, design, implementation, maintenance. Pretty similar to software. Database lifecycle is going to be your initial study, your database design, implementation, testing, operation, and maintenance and evolution. Okay, so there's the different steps in each of the life cycles. Let's talk about the homework that I'm going to have you do. All right, again, in this one, it's more theory. So I am going to have you do all 15 from the review. A lot of them are terminologies, and a lot of it is a review from previous chapters. I want to make sure you really do understand them. Again, I'd really like you to use your own words. Don't use the words from the book if you can avoid them. And then the problems. So 1A through F is kind of a multiple choice. Which one of these do you think should go first, and then why? Why do you think this, that, and the other? 2A and B, and then 6, A, B, and C, and then 7. None of these should be very difficult. They're just a little bit of why would you do this, and what do you think the purpose of this is? So I kind of want to know a little bit about your thoughts on why these things work and what you think that they would mean for you while you're writing your database. Have a great week, and I'll talk to you soon.